Today we are going to discuss this problem in which we are given an array containing only zeros and ones, and what we want to do is we want to find out the largest subarray, that is a set of consecutive elements which contains equal number of zeros and ones, and we want to accomplish this task in O(n) time, that is linear time. So what is the first step? We consider all zero values as -1. We may temporarily replace 2. So what we want to do is we just replace all the zeros in the array by -1. We will see next why we do it, but we do this. We replace all zeros by -1, and finally when we are done with solving the problem, we again revert the -1s to zeros. So this is the first step. What is the second step? We want to calculate cumulative I. So what is cumulative I? It is the sum of aj from j is equal to 0 to I. So this is cumulative I. So the sum of all elements till I is cumulative I, and from 0 till I is cumulative I. So we compute this array. Computation of this array will take only O(n) time. Why? Because we can write it like this. Cumulative of I is equal to cumulative of I minus 1, which we have already calculated, plus a I. So using this formula, this we have already calculated. This is the ith element, so we just sum them and we get. So cumulative I is calculated in O(n) time, and for all I from 0 to n, this takes O(n) time in all. Now there are two cases to consider. The output, that is the answer subarray, starts from index 0, or the output subarray do not start from index 0. Let us try to understand what these two subcases mean. Let us say the array is this: 0 1 0 1 0. So the answer is maybe this. In this case, the answer does not start. If we give the answer this, the answer is not starting from index 0. This is the 0th index, and so does not start from index 0. So this is case number 2. And starts from index 0. If we give this kind of answer, then this kind of output falls in case 1. Okay, the output is starting from index 0 of the array. So the output is basically two indices, the starting index and the ending index. So if the starting index is 0, we consider that as case 1. If the starting index is not 0, we consider that as case 2. So our answer must fall in one of these two cases, because either the starting index is 0 or it is not 0. Okay, so why we break our situation in two cases? Because we want to handle these two cases separately. So handling the case 1 is quite easy. return max of I such that cumulative I equals 0. Let us see how this works. This works because, let us say, this is the array 0 1 0 1. So this gets converted into what? Minus 1 1 minus 1 1. So this is 0th element, this is 1 element, this is 2th element, this is 3rd element. Okay, so cumulative 3 is equal to 0, cumulative 1 is also 0. So this is a possible answer. This is a possible answer because what cumulative I means, the sum of elements till the ith element, sum of all elements till the ith element. So cumulative 1 is 0, that means the number of ones till the 1th index is equal to the number of minus ones till the 1th index. That's why the sum is coming 0. That's why the equal number of minus ones and ones, but minus ones were originally zeros, so we have hence solved our problem, that is there are equal number of zeros and ones. So this is a possible answer, and this is also a possible answer, 0 to 3, because here the cumulative is again becoming 0. But why will return the maximum index, maximum such index where the cumulative becomes 0? Because we want the largest subarray. That was the problem. Let's see the problem. The largest subarray which contains equal number of zeros and ones. This is the problem. So that's why we try to return the maximum I here. So this case is the first case where this index is, the starting index is 0 and the ending index is the furthest we can go from here and get the cumulative is equal to 0. That's where the number of minus ones is equal to ones, that is zeros is equal to ones. So this is the case 1. This is how we handle the case 1. Let us now see how we handle case 2. So we use hashing technique for this. So how we hash, please listen carefully. So we keep a max which represents the maximum length of the subarray, largest subarray, and initially it is minus 1. If it remains minus 1, then no such subarray is there such that number of zeros is equal to number of ones. So what we do is like, okay, so we do this. We take an array hash and initialize hash I is equal to minus 1 for all I. So now you will ask, what is the size of this array hash? So what we do is we traverse the cumulative array from 0 to n minus 1, that is we traverse the whole cumulative array. Okay, and this is the hash array defined above. Whatever the maximum value in the cumulative array, we consider it as max, and whatever is the minimum value in the cumulative array, we consider that as a number called min. So the size of our hash array is max minus min plus 1, because whatever elements are in the cumulative array, whatever values are there, hash is used to hash those values. So let us see what it means here. So we traverse this cumulative array from 0 to n minus 1, that is we first see what is cumulative 0, then we see cumulative 1, then we see cumulative 2. So if let us say we are seeing cumulative 2 right now. So if the value is not present in the hash, that is hash of cumulative 2 is equal to -1, we do hash of cumulative 2 is equal to index, that is the leftmost occurrence of that value. I think we will consider this hashing technique in a separate lecture, because otherwise this lecture will be becoming too long. So thank you friends.